So this is video 2 for section 1.6. And in this next question, you're going to be looking at simplifying to a mixed root. So we're going to be taking our radicals that we have. So we have several different radicals, okay? And we're going to be simplifying them to a mixed root. So the way we do this is first we need to write a factor tree and factor our radical. So I'm going to factor 80, take out a 2, and I have 40, take out a 2, and I have 20, take out a 2, and I have 10, take out a 2, and I have 5. Okay, so I've factored my radical. Next, I want to find groups that match my index. So in this case, my index is empty, so that means that it's a 2. So I need to find identical groups of 2. So here we go. I have 2 2s, and then I have another group of 2 2s. But I don't have a partner for this 5. It's by itself. Okay. So I'm just going to leave it. I'm not going to circle it. I'm going to leave it alone because it doesn't have a partner. All right, so when I write, just like in section 1.3, now I'm going to rewrite with my exponents. So I get 2 squared for this bunch. I get another 2 squared for this bunch. And then I have a 5 all by itself. There's no partner for this 5, so I can't write an exponent on it. I'm just going to write a 5 by itself. So now, to simplify, I want to cancel any of where the exponent matches the index for any of those numbers. Okay, so it's the exponent matches the index here and here, but it does not match the index on the 5. There's no here. If you were going to write an exponent, it would be 5 to the 1, but and that doesn't match this index of 2. Okay, so there's no match here, so we can't take the 5. We can't get rid of the root sign for the 5. So what we're going to do is we're going to write our 2 times 2 without any root over them, as you would, we've learned previously. But for our 5, we need to leave it under the root because we were not able to cancel the exponent for that. So it stays with the root. Okay. Then we want to get rid of any multiplication that needs to be done. So we're going to multiply our 2 times 2 together, and that's going to give us 4, and then root 5, and that stays under the root. So this is our mixed root now. We have a 4 outside the root sign, and then we have a 5 that we needed to leave under the root. So that's our final answer for this one. Let's try another one. So we'll move over here. So in this one, we have 3 times root 32. So we're going to leave the 3 and ignore it for now, and we're going to write our factor tree for 32. So 32 can break down into 2 and 16, and then we can break 16 into 2 and 8. You can break 8 into 2 and 4. We can break 4 into 2 and 2. So we look at our index. Now remember, this 3 is not the index. For a number to be the index, it has to be really little and in here. This is just a 3. This is already a mixed root. Okay, and this 3 is just outside of our root sign. So we're going to look for identical groupings that match our index. So our index is 2, so we're looking for groups of 2. So we have 2 groups of 2. So now I'm going to rewrite this. I leave my 3 outside the root. It's just sitting there. I'm going to write 2 squared times 2 squared. So for this group, it becomes a 2 squared. Oops. This group becomes a 2 squared. This group becomes a 2 squared. And then I still have this 2 left over. So I'm going to write times 2. And that's going to be underneath the root. Then I can cancel any exponent that matches my index. So I know my index is 2. So those exponents can cancel and they move outside the root. I'm going to write that over here too. So when they cancel, they move out of the root. That little arrow means that you don't put the root sign over them anymore. Okay? So the 3 is still there. It's outside the root. Now it's going to be multiplied by a 2 and another 2, the two 2's that I moved outside the root. And then I still have a root 2 in the root. So now I can simplify. I can multiply 3 times 2 times 2 together. It's going to give me 12 root 2. Okay, so my 2, which didn't have a partner, is left stuck under the root. The 3 was already outside the root, and then my 2 2's moved out. So that's my final mixed root answer for this one. We can now try some where the index is a different number, not 2. So here we have an index of 3. So we're going to be looking for identical triplets of numbers. So we can start off by factoring 162. So we get 2 and 81. And then 81 divides by 3. So we get 3 and 27. And then I can take another 3 out and I get 9. And then 3 and 3. So I'm looking for trios. So 2 doesn't have a partner. Then I have 3 3's together. And then another 3 by itself. So I can rewrite this. I write my root sign. I fill it with my 3 to match my index for my original question. And then I have 2 times 3 to the 3 times 3. This exponent matches my index, so I can cancel it and move this outside the root. I can rewrite this now as 3, and I make sure to keep my little 3, try and keep it contained within the swoosh of your root so that you don't get confused. You don't want it to look like you're writing 3 to the power of 3, okay? The 3 is separate from the root. And then you have 2 times 3 still inside your root. And then you're going to simplify 3. You can multiply the 2 and the 3 together, and you get 6. So now the answer as a mixed root for this question is 3, the cube root of 6. 3 times the cube root of 6. So we'll do one more example. Here we have an index of 4. So we're going to factor this one. We have 2 and 81, 3 and 27, 3 and 9. Oh, we just did this one, 3 and 3. I didn't notice. All right, so now we're looking for an identical group of 4. So here we have 4 3's together. Okay. So when we write this, we write an index of 4, 2 times 3 to the 4. And now our exponent that matches our index cancels out. This moves out of the root. So we get 3 with a 2 still in the root. So our final answer for our mixed root is this. Okay, so at this point, you're going to pause here. This is the end of part 2 video. You're going to go to page 53, and you can do number 3, just the left-hand side of number 3, number 4, A to F, and number 5, A, C, E, and G. And then we'll come back for one more video for the last part.